Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today our class is after 3 days due to some technical inconvenience. So I'm so sorry for the delay of the class, or we can say the cancellation of the class. So now let's start with the today's class, or what we say the previous class session, or what we have covered in the Monday's class, and then move to the today's class only, right? So we have cancelled, or this class have cancelled for 3 days, that is for Tuesday, Wednesday, Thursday, that is for 28th, 29th and 30th of July. Now listen carefully. Now today there is a class, and tomorrow, that is Saturday, there is also a class, because due to the backup of the previous classes, or we can say the recover of the previous classes. So tomorrow there will be a class. According to the IST, it is 2 o'clock. So instead of 4 o'clock, it is 2 o'clock, for the, that is 2 to 4 according to the IST, right? So let's start the session with the previous class session. In the last class, that is in the Monday's class, we have started with the chapter number 11. This is chapter number 11, that is indexing and the hashing. That is what is the meaning of indexing and what is the meaning of hashing. That is how we can do the indexing and the hashing. That is what are the various terms that is used in the indexing and the hashing. So we have discussed about the hashing, we have discussed about the indexing, that is index is maintained to maintain the record, that is the index, and there is a hash table that is used to maintain the hash properties, that is used to maintain what type of properties, what type of department that is dealing with. So we have a concept, or we have studied about the basic concept, that is the index or a file, or index for a file in a database system works in the same way as we do in the textbooks. If you want to learn about a particular topic, then we can do it. Find the pages where it occurs, like an index of your book. In the same way, there is an index that is maintained in the databases. That is the index that is used to give the priority, that is used to find out the records from the databases, that is in a efficient manner, easiest manner, and we can say that there is no duplication of the records in the database. And there are two types of indices that is available in this one is the ordered indices, one is the hash indices. So when we sort the order, or when we sort the records according to the, or when we sort the records according to the indices, that is known as the ordered indices. And there is a hash indices that is used, or that is based on a uniform distribution of values across a range of buckets. The bucket to which a value is assigned is determined by the function that is known as the hash function. So one is the order indices, one is the hash indices, and there is a hash function that is used to determine which value will be assigned to the hash table and what value will be assigned. Then we also studied about that there are different criteria, there are different factors on the basis of which we can evaluate what are the, or what is the main factor that is used for the hashing technique, that is used for the indexing techniques. So first is the access time, that is the how much time, or we can say the time taken to find a particular word or particular data item, that is known as the access time. Then there is the access type, that is what type of records, what type of attributes that is available for accessing the hash function, that is the access types. Then there is the insertion time, that is how much time is used to insert the data into the database, that is the insertion time. Deletion time, that is how much data is required, or how much time it takes to delete a data item. That is first of all pick up the item, then take the time to update the index structure. Then there is a space override, that is the additional space that is occupied by the index structure. Then we have talked about in detail what is the ordered indices, how to use the ordered indices, what are the various benefits to use the ordered indices. So to gain the fast random access to the records in a file, we can use the index structure, and there is a ordered indices, that is the sequence will be maintained, that is how to do the order, or how to maintain the order in a index, that is the ordered indices. And there is a clustering index that is also available, that finds the keys, search keys in a sequential order or a file. So we can find the keys in a sequential order by the use of the clustering index. This is one of the example that we have discussed. And the clustering index, sometimes also known as the primary indices, because this is the primary one that is used for locating the terms, for locating the values. Then there are other indices also, that is the non-clustering indices, secondary indices, that is also referred as the clustered, and the non-clustered, that is often used in the clustering part. And we can use the files with the clustering index on the search key, that is used for the searching the concept, that is known as the index sequential file. So there is an index sequential file that is used to find out the index, that is used to find out any particular record in a sequence way, that is known as the index sequential file. Then next is the dense and the sparse indices. There are two types of the ordered indices, that is the dense and the sparse indices. This is the dense index. In the dense index, every entry or every index entry appears for every search key value in the record. In case of sparse index, there is an idea or there is an index entry that appears for some of the search key value. That is, there is not that every search key is used in a file. No, but some search key is used in a file in the case of the sparse index. Then we also discuss about the multi-level indices. That is how to use the multi-level indices for various blocks. Then how to update the index. There are three criteria, different criteria. For insertion purpose, there is a different criteria, and there is a different criteria for the dense index. There is a different criteria for the sparse index. So index updation means how to update the index. What is the value that is given in the index? So first of all, there is an insertion, that is how to insert the data, how to insert the records in a database, that is the insertion. And for insertion purpose, there is a dense indices, and there is also insertion in the sparse indices. There are two categories. This is the dense indices. Then there is a deletion of the dense indices. There is a deletion of the sparse indices. This is the insertion of the sparse indices. In the same way, we can update the records, we can change the records in the case of the sparse and the dense indices. Then the next indices is the secondary indices, that is used or that is must be dense with the index entry for every such key value and a pointer to every record in a file. That is a pointer is locating to the file that is used for the secondary indices, or that is used for the index, that is used to maintain the record, that is available in the sparse index, that is available in the data index. A secondary index or on a candidate key looks like just like a dense clustering index, except that the records pointed by the successive values in the index are not stored sequentially. The main point is that the values are not recorded sequentially, that is in the order in which it is maintained. A sequential scan in clustering index order is efficient because the records in the file are stored physically in the same order as the index order. This is one of the secondary index on the instructor file or the non-candidate key salary. Then next is the automatic creation of the indices, that is how to create automatic or how to automatically create the indices that is available in the sparse matrix. Then indices on the multiple keys, that is known as the composite search key, that is used for the various attributes. So if there are more than one attribute that is available, so we can also set the indices on the multiple values, multiple keys. Then we also talked about the next topic, that next concept, important concept, that is a B plus tree index file. That is a what is the meaning of the B plus tree B plus index file that is used for the maintenance of the data. So the main disadvantage of what we have covered is the index sequential file is that performance degrades as the file grows. So when the file grows in the record, file grows in the database, the performance will be degrade. We can say the system will be hang, there will be index lookup, and for the sequential access there will be a sequential scan throughout the data. Although this degradation can be remedied by the organization of the file or reorganization of the file in the B plus tree. And the B plus tree in tree structure is most widely used of the index structure that is used to maintain the efficiency as well as the contingency. So this is the balanced tree. That means a B means the balanced tree. That is, there is no efficiency lost, there is no data loss that is available in the B plus tree. Then what is the structure of the B plus tree? There is a leaf node that is available, that is overlap with the multiple keys. And what are the non-leaf keys? That is known as the or that forms a sparse indices, and the multiple values are known as the internal nodes. Next is the queries on the B plus tree, that is how to make the queries. Simply put the queries like this one. This is the function that returns the queries that is used for the insertion key. Now next is the updates on the B plus tree, that is how to update on the B plus tree, that is the today's topic. So let's start with the today's topic, that is how to make the updations on the B plus tree. So the next topic is updates on the B plus tree, that is how to make the updations in the B plus tree, or how to make the updations on the B plus tree. So if there is updation that is available in the B plus tree that is used to update the values, update the trees, update the insertion, update the, we can say the deletion, that is the updations on the B plus tree, right? So when a record is inserted or deleted from a relation, then the indices is maintained on the relation that must be loaded or that must be updated correspondingly. So when a record is inserted into or deleted from a relation, indices on the relation that must be updated correspondingly. So when a record is inserted or deleted, there must be a updation in the records, there must be a deletion in the record, there must be updation in the records in the relation correspondingly. Recall that updates to a record can be modeled as a deletion of the old record followed by the insertion of the uploaded record. So there is a deletion of the record, there is uploadation or the upload of the record, that is a deletion of the old record, and insertion of the new record, that is known as the deletion or that is known as the updation of the record. So when we talk about the updation, that means delete the previous record or delete the old one and update the new one. Hence, we will only consider the case of the insertion and the deletion. Insertion and deletion are more complicated than the lookup. So that will be more complicated in case of the insertion and the deletion. And since it may be necessary to split a node that becomes too large as a result of the insertion or as a result of the coalesce nodes, that is a combined nodes. If the nodes become too small, that is by the n by 2 pointers. Furthermore, when a node is split or pair of node is combined, we must ensure that the balance is preserved. So if the node is split or if we combine multiple nodes, that means we must ensure that the balance is preserved. There must be a balance between the split up node and the smaller nodes. So to introduce the idea behind the insertion and the deletion in B plus tree, we shall assume temporary that nodes never becomes too large, never too small. So if there is a too large nodes, we cannot insert the data, we cannot delete the data. That is too small, that is there is no memory, so we cannot insert the data. Under this assumption, insertion and deletion are performed as defined next. Now there is an insertion, that is how to make the insertion. So means the main concept is that there will be no deletion, there will be no insertion. So there will be a balance between the insertion and the deletion of the nodes. Then first part is the insertion, that is using the same techniques as for a lookup. We find the find function, we use the find function to insert the data. Then we first find the leaf node in which the search key value would appear. So if I want to find anything, if I want to insert anything, so first of all find the leaf node in which the search key value would appear. We then insert an entry, that is a search key value and record pointer pair in the leaf node, positioning it such that the search key are still in order. So we then insert an array, insert an entry, that is insertion and entry, that is used for the search key values, and the record pointer pair in the leaf node, that is used for describing the value, that is used for repositioning the value, that is used for repositioning the values that is available in the node. So insertion means using the technique that is used for inserting the value, that is used for the lookup value, that is used for the find value, that is used as a leaf node with the search key value that would appear. We then insert an entry, that is the search key value and the record pointer pair in the leaf node, positioning it such that the search keys are still in the order. So find out the search key, find out the locate key, find out the search key value that is used for the inserting the values. Then there is a deletion, that is using the same techniques as for lookup. We find the leaf nodes containing the entries to be deleted, that is which entry to be deleted. If there is that is a leaf node, that is there is no other nodes, there is no other child that is available in the insertion. So if there are multiple entries that is available with the same search key, we search across all the entry with the same search key value, that is used to find the value, that is used to find the detect the value, that is used for the deletion. All the entries in the leaf node are that to the right of the deleted entry are shifted left by one position, so that there are no gaps in the entries after the entry is deleted. So if there is no gap in the entry, that is the entries is deleted. Now we now consider the general case of insertion and the deletion, dealing with the node splitting and the node coalescing. So now we consider the general case, that is how to insert the data, how to delete the data. Now this is the splitting of the leaf node on the insertion of the atoms. This is the insertion. We now consider an example of the insertion in which a node must be split. So there is a node that is split into multiple parts that is used for the insertion part. Assume that a record is inserted on the instructor relation with the name value being atoms. So if I want to insert any value, if I want to insert the name of the instructor, that is name is the atoms. We then need to insert the entry for the atoms into the B plus tree of figure 11.9. So what is the 11.9 figure? Let's see quickly. Hurry up. This is the 11.9. We want to insert the value of the atoms in the figure 11.9 over here. So we then need to insert entry for the atoms into B plus tree of 11.9. Using the algorithm for lookup, we then find that the atom should appear in the leaf node containing the branch, caliphree and the clay. So atom will appear in the leaf node, that will appear at the end, that is available in the branch, caliphree and the clay. There is no room in this loop or leaf to insert the value, that is the atom. Therefore, the node is split into the two nodes, or the node is split into the multiple part, that is known as the same node will be divided into two parts, split into two parts, that is shown in the figure 11.12, that is the atom, branch, caliphree and the crick. The search key value, that is the atoms and the branch, are in one leaf. This is the search key values, and the caliphree in the other nodes. In general, we take the n search key, that is the n minus 1 values in the leaf node plus the value being inserted, and put the first, that is n by 2 in the existing node, and the remaining values in a newly created node. Having split a leaf node, we must insert the new leaf node into the B plus T structure. In our example, the new node has a caliphree as its smallest key values. Now, splitting of the non-key leaf node is a little different from splitting of the leaf node. So this is how to split the non-leaf node, that is the very we can say the easy as compared to the leaf nodes. This is the insertion of the Lamfort in the B plus tree. That is one of the example that is given. This is the, we can say, the program that is used to insert the values. Then next is the deletion. Now we consider the deletion that causes the tree is not to contain too few pointers. Let us delete the one of the point, that is a Srinivasan from the B plus tree. So now let us delete one point. Let us delete one, we can say, the name of the instructor, that is a Srinivasan from the B plus tree. The resulting B plus tree appears in the figure 11.16. This is the 11.16. That is the deletion of the Srinivasan from the B plus tree. We now consider that how deletion is performed, that is how we can delete the data. We can delete the entry for the Srinivasan from its leaf node. The node is left with only one entry, that is a WU. Since in our example n equals to 4 and 1 is less than n minus 1 by 2, we must either merge the node with a sibling node or redistribute the entry between the nodes to ensure that each node is at least half full. That is, every node is available in a half full manner. In our example, the wonderful node with the entry for WE can be merged with its left sibling node. So the WE node or the WE instructor will be merged with the new sibling or the left sibling node. We merge the nodes by moving the entries from both the nodes into the left sibling and deleting the new now empty or the new empty right sibling. Once the node is deleted, we can move the, or we can also delete the entry for the parent node at this point, the deleted node. This is one of the example, that is the deletion of the sync and the WO from the BU or the B plus tree. This is the deletion of the gold from the B plus tree. Then next concept is the non-unique search keys. That is, what is a non-unique search key, or what are the various concepts, that is how to use the non-insert or non-unique, that is not unique, that is a non-unique search keys. So the relation can have more than one record containing the same search key value. So if they are containing the records, or if they have a record that has no that have more than one record that containing the same search key values, that is two or more records have the same values for the index attributes, the search key is said to be the non-unique search key. So there is no non-unique search key that is used for the unique values. One problem with the non-unique search key is in the efficiency of a record deletion. That is, if there is a non-unique search key, the deletion is very difficult. We cannot delete the data very easily. One problem that is available with the non-search key is that efficiency of the record deletion. That is, there is not, we can say, there is no efficient or there is no proper efficiency in the deleting the records. A simple solution to this is that we use the database system to make the search key unique by creating a composite search key containing the original data. So we can use the search key that is used to original data. This is one of the example. We can say the program that is used the deletion for the B plus tree. Then there is a complexity that is available in the B plus tree. That is how complex or what is the main complexity in the B plus tree updates. So this is available in the form of the log n by 2 n. That is available in the insert key. So the worst key or the worst case complexity of the deletion procedure is also proportional to the log n by 2 n. That is provided that there are no duplicate values for the search key. That is, there is no we can say the repeated value in the search key that is available in the log n by 2 n. Now next is the B plus tree extension. That is, what are the B plus tree extensions? How to use the B plus tree extensions? So the next topic is B plus tree extension. That is, what are the various extension that is used in the B plus tree, or what are the various, we can say, the terms, we can say the content that is used in the B plus tree. That is a B plus tree extension that is available, or that is known as the extension, or we can say the next part of the B plus tree or B plus tree. So in this section we discuss several extensions and variations of the B plus tree. That is, what are the various variations in the B plus tree, and what are the various extensions, we can say the add-on varieties of the B plus tree index. So the first part is B plus tree file organization. That is, what is the file organization? What is the B plus tree file organization? So as mentioned in the 11.3, the main drawback of index sequential file organization is the degradation of the performance as the file grows. So one of the limitation of index sequential that we have discussed earlier also, that is it degrades its performance, or we can say the performance is down when the file grows, or the file level, or we can say the file size grows. With the growth, an increasing percentage of index entries and actual records become out of order. So whenever there is a file degradation, whenever there is a problem in the percentage of the index entry, so there will be a stroke out, or there will be actual record that will becomes out of order, that is records in the outflow or outflow blocks. We solve the degradation by using the file organization by we can say the organize the B plus tree in a variety of concepts, in a variety of files. That is, a loop nodes of the tree stores the record instead of storing the pointers. Since records are usually large than the pointer, the maximum number of record that can be stored in a leaf node is less than the number of pointer that is stored in the leaf node. So this is one of the, we can say, the organization, that is, we can store the values, we can store the number of records in a leaf node instead of the number of pointers in a non-leaf node. However, the leaf nodes are still required to be at least half full. That is, the leaf node is still required to be the half full values. So this is the I, this is the C, then F, K, M. So these are the various varieties, that is how to organize the file. This is the A4, that is the fourth level, then B8, then there is the C1, D9. So these are the various levels, these are the various, we can see the pointer that is used for the leaf nodes. Insertion and the deletion of the records from the B plus tree file organizations are handled in the same way as we have done in the B plus tree index file. So this is the same exactly what we have covered in the B plus tree index, that is used to record the value, that is given any value, that is the V is inserted. The system locates the block that should contain the record by searching the B plus tree for the largest key in the tree values. When we use a B plus tree for the file organization, the space utilization is particularly important, since the space occupied by the records is likely to be much more than the space occupied by the keys and the pointer. That is, the keys will be used to move the pointer, that is, the keys will be used to access the pointers. During the insertion, if a node is full, so if the node is full, the attempt will be used to redistribute some of its entry to the adjacent node. That is, inserting the data will be available to the adjacent node that is available in the nearby node, that is used for the different concepts. During the deletion, if the occupancy of a node below 2n by 3, that is a 2n divided by 3, the system attempts to borrow an entry from one of the siblings nodes. So if there is a lack of the data, so the term or so the record will be updated or record will be borrowed from the other sibling nodes. If both the sibling nodes have 2 by n by 3 records, instead of borrowing an entity or entry, the system redistributes the entries in the node and in the two siblings evenly between the two of the nodes and deletes the third node. That is, it is used the concept of the 2n by 3 for deleting the record, for inserting the records. Next, how to perform or how to use the secondary indices and the record relocation. So there will be a secondary indices that is available that is used to reload the record. So some of the file organizations such as the B plus tree file organization may change the location of the records even when the records have not been updated. So it change the location, it moves the location, it rotate the location. A widely used solution for this problem is as follows. In a secondary indices, in place of pointers to the index records, we store the values of the primary record. So we store the value that is used for the primary record that is used in the content of the data. For example, suppose we have a primary index on the attribute ID of the relation instructor. Then a secondary index on the department name would store with each department name a list of the instructor's ID value of the corresponding records. So instead of recording the pointers, the values will be recorded. Next is the indexing strings. That is, what is the indexing strings and how to use the indexing strings, or what is the main advantage of using the indexing or indexing strings. Now the index will be maintained on the strings also. So creating the B plus tree indices on the string values attribute raises two problems. So there are two problems that is faced for using the indices, that is stores the value, that stores the value in case of the index string that is used. The first problem is that string can be of variable length. So there are two problems or there are multiple problems that is used with whenever we use the index with the or whenever we want to search anything from the string. The first problem is that the string can be of variable length because there is no fixed criteria that the string will be of 24 bytes, the string will be of 25 bytes. No, but the string will be of multiple length, string will be of variable length. The second problem is that the string can be too large. So if we insert the value, if we insert the data that is used, that is we can insert the value that the string is very long or can be very long, leading to the low fan out and the correspondingly increased tree height. So it will be increased the tree height that will be used for the data insertion. With variable length search keys, different nodes can have different fan outs even if they are full. The fan out toward the nodes can be increased by using a technique that is known as the prefix compression. So there is a prefix compression that will be used to store the values. Then next is the bulk loading of a B plus tree indices. That is how to load the bulk or how to load in the bulk. That is how to use the bulk loading of the B plus tree indices. So insertion of a large number of entries at a time into an index is refers to the bulk loading of the index. So whenever we insert the values, whenever we insert the entries at a time to an index, so there are multiple entries, large number of entries that will be inserted in the index, that is known as the bulk loading of the index. An efficient way to perform the bulk loading of an index is as follows. That is, the procedure that is used for the bulk loading is as follows. So there is a significant benefit to sorting the entries before inserting them into the B plus tree. So when the inserted or when the entries are inserted in the sorted order, all the entries that go to a particular leaf node will appear consecutively, and the leaf node will use and the leaf node will be done that is used to perform the or that is used to return only once. And the nodes can will never have to read from the disk during the bulk load. If the B plus tree is initially empty, so if it is initially empty, it can be constructed faster by building it bottom up from the leaf level instead of using the usual insert procedure. Most of the database system that implement the efficient techniques based on the sorting of the entries and bottom of construction when creating an index on a relation. So whenever we use a database system that is used to insert the data, that is used to insert the content, that is used in the insertion part. Next, B plus or the B tree index files. So B tree indexes are similar to the B plus tree indices. That is very similar to the B plus tree indices. That is a B tree indices. The main difference is that B tree eliminates the replication, redundant storage of the data that is used by the search key values. In the B plus tree, the search key that is, for example, the caliph-free instant gold appear in the non-leaf node in addition to appearing in the leaf node. Then next is the flash memory. That is how to use the, or what is the usage of the flash memory that is done in the concepts of the B plus trees. So in our discussion of the indexing so far, we have assumed that the data resides on the magnetic disk. Although this assumption continues to be true for the most of the parts. Flash memory capacities have grown significantly and the cost of the flash memory is increased or will be decreased or will be increased as per the concept that is used in the flash memory storage. Natural question arises, that is how this change, if we using the flash memory, how the change will be reflected in the index structure. So the flash memory storage that is used to store the data that is structured as a block, and the B plus tree structure can be used as a flash memory storage. And the benefit of using the flash memory storage is that there will be a more fast access speed as compared to the index lookup. The one of the drawback, one of the limitation is that it does not permit the in-place update so to the data at the physical level. That is, there is no update to the physical level that is used with the flash memory. That is one of the limitation of the flash memory. Now next is the multiple keys access. That is how to access the multiple keys. That is the multiple keys access. So there is a concept how to use the multiple keys access. That is how to access the value that is of the multiple types. Now that is, or this is one of the important concept that is used in the trees concepts. So we have assumed the implicitly that only one index on one attribute is used to process the values or process the query on the relation. However, for a certain types of queries, so if we are using the certain type of queries, it is advantageous to use multiple indices if they exist, or to use an index built on a multi-attribute such value. So the first concept is that using the multiple single key indices. That is what is a multiple single key indices that is used in the fast growing strategies. So that's all for today's session. Thank you so much everyone for listening me. Now there will be a class tomorrow, that is on Saturday, as per the IST, that is the 2 to 4 p.m. Remember, tomorrow is a class from 2 to 4 p.m. as per the IST, right? Because I've taken the class on the Saturdays because 3 days are over and 3 days of class from cancelled. So to recover from that classes, I have to manage that class this Saturday, that is from 2 to 4. So tomorrow we will meet at 2 to 4 as per the IST. Alright. So bye bye everyone.